We are about to use this multimeter to diagnose why my sailboat's running lights are not turning on. Stick around until the end and I will show you the tool bag I use to troubleshoot, fix, and upgrade my boat's electronics. Hi, I'm Sailor Eric. If you are a boat owner or enthusiast, you know how frustrating it is when your electronics fail or malfunction. That's why having the right tools and knowledge is essential for troubleshooting and fixing problems fast. Faulty wiring is one of the most common issues we see on boats. Corrosion, worn out insulation, and loose connections can all cause electrical shorts and failures that can be difficult to track down. The list of potential electronic issues on a boat is a long one, and many of these problems can be quickly and easily diagnosed with a basic understanding of your boat's electrical system and the multimeter. In fact, a multimeter is one of the most essential tools you can have in your toolbox when it comes to troubleshooting boat electronics. Let's first review how your boat's electrical system is set up. In general, you'll have a DC battery bank as the primary battery source of your vessel. This is how mine looks. This bank of batteries will generally have one main connection leading out and another coming back. The wire leading out will be the negative line, which code standards suggest is going to have either black or yellow insulation. The positive wire represents the return of the circuit and is colored red by code standards. When a circuit is complete, a chemical reaction is triggered within the battery housing, which generates energy and power. This draws electrons out through the black or yellow wire. Any item that requires power from the circuit must be connected to both the positive and negative lines. Switches are used to interrupt or break the circuit. Okay, that's it. There is much more to learn about a boat's electrical system, but that's enough for you to understand and troubleshoot the system with a multimeter. By turning on other electrical devices on my boat, I know immediately that the battery is working. And the likely issue is either with the wires leading up to the light or the light itself. I also know that prior to the end of my last sailing season, a furling line was caught around the running light wires, and there was excessive pulling on these wires. So that's going to be our starting point today. It's going to be right where the device is connected to the circuit. We will turn the switch off to the circuit. We'll then disconnect the wires so that we can connect the multimeter to them. Then we will turn the switch back on, which will send electrons through the circuit if it is connected. For background knowledge, the voltage is the total capacity of the battery shown in real time. A full 12-volt rated battery can read at anywhere between 12.6 and 14.5 volts of capacity. For troubleshooting, we're just happy to see if we can see the battery's voltage. It means we are connected to the battery through the wires, drawing power. This is the light. This is the connection from the main circuit, which runs through this piping back toward the battery. And these leads go right to the device. And I just turned on the switch. The light didn't come on. I turned it back off. Now what we're going to do is we're going to expose these connections. We're going to peel off this electrical tape. So it was a bit painful to pull all that stuff off. But in doing so, this connection came out of the back of this. It could have been already out and just I exposed it by pulling on that tape. Or this was connected legitimately and I still have a problem to solve. But nonetheless, we're going to take off these connectors like that and like this. Okay, so this is the circuit, the main circuit. And I went down and I turned this on. So now there's power coming through there. And we're about to test this out with the multimeter to see if we can actually see the voltage coming back from the battery bank. This is the positive. We're going to put the positive in the positive circuit. We're going to put the negative in the negative circuit. And voila, I've got 12.6 volts showing up in the multimeter. Here's the multimeter, 12.6 volts. Okay, so that tells us that the power is coming through this main leg just fine. And only the connection, it seems like, from here to the light is the problem. So given that we found that this was out of the connection block, we just need to add a new connector to this and then connect the whole thing up and the light should come right on. Woohoo! Okay, here's the exposed wire. There's no power coming from here. This is the wires again leading to the device itself. And here is a male clip connector right here. And we are going to crimp this on. This is my crimper, and I'm going to fit the end of this into the appropriate sized gauge for the crimp. And as simple as that, I've just now crimped this connector to the wire. You can see that is now on. And now we'll connect these again and see if we get light. It's connected. But I have no light. So there's still an issue here. I think these connections are looking good. I'm going to test that theory. The conclusion at this point is that I need to replace this piece of hardware, put a new bicolor up here, which is important for safety reasons when sailing, especially at night. You're going to want to have a green and red light up there. That is just part of the international regulations. You can be stopped by the Coast Guard if you do not comply. It's just safer, right? So we definitely want this working for next season. I think these connections are good. I think this fixture is now bad. It's old. To replace it, I'm going to have to get potentially a smaller fixture. This is an older fixture, an older boat, and when you replace parts on a boat, generally it's going to be something more modern, newer, probably smaller, and you're going to have to relook at how it's mounted, maybe change the configuration of the mounting a little bit, so I'll have to go through that. But I do want to test the theory that power is running through these lines into the fixture itself. So what we're going to do is we are going to cut these lines further up, and we're going to verify that we have connections. If we don't, then we can just reconnect a little further up the line and then try this whole thing again. Okay, the first thing to do for this experiment is we're going to cut these wires. Okay, so now this circuit is disconnected. It's still hot, and I should be able to test it. What I'm going to do is I'm going to take these connectors off here, and I'm just going to strip the insulation off of each of these so we can then have bare leads to connect. This is a wire stripper right here, and I believe this is probably 14 gauge wire. So I'm going to put it in the appropriate slot here and then pinch down on the clamp and then pull. And you can see I just pulled that insulation off of the wire to expose it. Here on the back you can see the little measurements for the gauges. I'm choosing 14 gauge. I'm going to put the end of the wire through here like so, squeeze, and then pull, and then it exposes the wire, right? It pulls the insulation off. I'm going to reconnect these connectors to the hot side of the circuit. Okay, so this test has proved out my theory. The leads are connected, and I've got 12.6 on the voltmeter. So this is proving that current is coming through the circuit, through those connections, and out the other end. So knowing that, before I snipped this line, I have pretty good confidence that current was getting all the way into this housing. And I can see that this housing is a little stressed. We're going to start taking off this light, which we will have to do to replace it anyway. We got a couple of screws and a zip tie. I went ahead and pulled off that C bracket that was installed or mounted on this block, and I've replaced it with two smaller L brackets. And this is the smaller fixture that we are replacing the old fixture with. I'll tell you that while I was at home over the weekend, I took apart that old fixture and got it to work. But you know, an old fixture where these wires have been pulled and the connections down at the base of the light are in question, I did not want to reinstall that, even though I fixed it. So now what we're going to do is we're just going to make sure these wires, when they connect to the battery, are lighting up. You can see that I've got a connection in there when I have both wires in. We're going to install this housing. It's the bicolors cover. There's two screws that I have to screw from the front of the fixture. The next step is to put the disconnect connectors onto the ends of these leads. This is smaller gauge wire. It is approximately an 18 to 20 gauge, which means I'm going to have to use a connector that has a smaller gauge hole that you put the lead in, because this is male, right? The positive here is male. So I need a female connector on the positive over here, and here the negative connector is female, so I need a male connector on the negative over here. We'll start with that. We'll start with the negative, and there you go. We'll put that in, and we will crimp, and that's on. Okay. Do the same thing with the other connection. We'll feed in the lead so that it's in nice and taut. We'll put the crimper on it. Okay, so now these are crimped on. They don't want to pull off, right? Now we're going to use a butane lighter to try to melt a little bit that housing so that it kind of adheres more to the wire. All right, not bad, but we're going to reinforce that again. So now we should see this light come on when we connect these guys. And look at that. That light's on. You can tell very easily from there, right? So that's the whole point of the exercise, to get that light on. So that feels good. Now we're just going to cover this with electrical tape. Okay, we'll take a smaller zip tie and just gather this line right here, this wire, so that's a little bit out of the way. And then we'll take a longer zip tie and zip tie it to the piping up here on the pulpit. Okay, so I'm trying to show you. There you go. Okay, I promised at the end of this video that I would share my electrical tool kit, my tool bag here And we're going to start with this ammo box that's full of connectors. These are the different types of connectors I use on a boat. Usually I use anchor connectors, that's the brand name. And I have spade connectors, ring connectors, quick disconnect connectors, clip connectors, or ball clips, right? And I have the different gauges. So the different connectors could fit a small gauge or a large gauge wire. I have the different options in here. I also have some fuses. I have some different runs that have their own individual fuses within this boat. So to carry extra fuses is helpful. Mini screwdrivers are good to get into different fixture housings. I carry wire nuts, but I don't use them on the boat. I only use them for very quick connections, temporary connections. So I can put something together and then come back to it and then connect it properly. I have, of course, the multimeter, which you saw in action multiple times. This is key for electrical troubleshooting. The crimper to connect the connectors to the ends of wires. That is hugely important. Small screwdrivers, Phillips head screwdriver, a pair of needle nose pliers, which are handy, and it can clip wires at the base of the needle nose pliers. We've got clippers or snippers themselves. That'll be useful. This is to strip. These are wire strippers. Basically strip the insulation from the wire. Very handy. I've got some wire itself. I've got multiple spools of red and black or yellow wire that can run the length of the boat. I have primarily 14 and 16 gauge wire, which I find the right amount of gauge to facilitate a 12-volt electrical system. And this is marine grade wire. It's tin copper with multiple strands within a single insulating bracket. So basically, you want a bunch of strands all bundled together as opposed to one specific thick strand, because the multiple strands provides redundancy for the connection. If one thick wire breaks, then that's it. The whole run is bad. But to have all those individual wires creates this little level of redundancy, and it's more malleable. It's much more flexible. It can go around corners. I've got a number of terminal blocks, which facilitates many-to-many connections or one-to-many connections, depending on the type of terminal block. And that's useful for points within the boat that you're using as a hub for the electrical system. Electrical tape, I have multiple colored electrical tape. I've got a razor knife in here. I've got an extra knife as well to cut. You always need to cut different areas of wire. And I have some test connectors too. So you can connect this to a battery or a terminal end and connect the other end to a lead or something like that to facilitate, whether it's a test or to do a temporary connection to an alternate source, like a battery, an extra battery, that just to verify that the thing works as opposed to the run. It's another way of troubleshooting. That's the gist of tools that I use for troubleshooting. Understanding your own boat's electrical system is paramount to getting to the bottom of most electrical issues. You can gather further information on how boat electrical systems work through reading books, watching YouTube videos, conducting experiments, and working on your own system hands-on. You might be surprised to find out that you can have fun doing it. Please leave a comment below if you would like to see more content like this, ask questions, or share your own troubleshooting experiences. I'd love to hear from you. Thanks for watching.